In this last video lecture, I'll talk about homogeneity testing. And this is, I think, where the multi-group analysis becomes really interesting. And we can start doing that after we established in part measurement invariance. So what do we want to do in homogeneity testing? Well, here we want to test for differences in means and in latent variance covariance structure. So basically, if this distribution is different between groups at the latent level. And that might be the part where we're interested in. So is group 1, does the group 1 have a higher level on the trait than group 2? Or is the spread bigger? Things like that. Maybe we can even look at the correlational structure and things like that. Right? So that will allow us to do things that are very similar to Manova's test, Levine's test, things like that, but then taking measurement error into account on latent variables, which is awesome. Alright. So in our drawing, what we're interested in now is differences in these psi and these alpha parameters. And when we establish in part measurement invariance, these things become identified. So what we can do now is again test a model where we set this to 0, then compare it to the model where it's not 0, but then that model is actually, that's a meaningful comparison, because this alpha was identified. So we get something that's interesting. And at least partial environment invariance is required to test these hypotheses to make these parameters identified. And the more things that are invariant across the models, the better. Across groups, the better. So what can we do with configurable invariance? And that means that we have the same zeros in the lambda structure. So we have the same model basically, the same Greek letters, but they are different across groups. Everything is different across groups. Well, that doesn't really allow us to test anything homogeneity-wise other than, okay, the same structure test fits in both groups. With weak invariance, it means that the factor loadings are equal, or at least part of the factor loadings are equal. We can test if the latent variance covariance matrix is equal or not. So then we can do a homogeneity test to say, are these equal? And then compare it to a model where they're not equal. And then we have a nice test value to see if they are equal or not. With strong invariance, where we also put the intercepts to be equal, we can test if latent means are equal or not. And finally, with strict invariance, where we also put the residuals to be equal, we can test for full homogeneity, or that basically means we can test if the correlational structure is exactly the same across groups. Now, ideally, we first go down this path as far as we can, and then we can establish these tests. So while we can already do this with only having equal factor loadings, we ideally want to go as far down as possible to the invariance model to start doing the homogeneity test. So we have an as parsimonious model as possible. Okay, so what does that look like in Lavaan? Well, it's exactly the same as we did before. We used this group equal argument. It's the exact same thing as measurement invariance testing actually. We just call it different, because we're now interested in things that are not really related to the measurement, but really related to structural properties of the groups we're interested in. So that's why we call it homogeneity testing, but it's not different at all. So we just say we are now want to constrain like the latent variances to be equal or not. And then we can do a test and see if the latent variables can be constrained equal. Well, the p-value is very not significant. AIC, BIC both indicate here that the model where the variances and the variance covariance structure at the latent level is equal is preferred. So then we do that, we accept that model because it's a more parsimonious model. And then we can also look at the means. And that might be the thing that might be most interesting. So now are the means also possible to constrain, is it also possible to constrain the means to be equal? And now we get a very significant p-value. We get a lower BIC and a lower AIC, or a higher AIC, a higher BIC. So that means that we prefer the model with only equal variances and not equal variances and means, because this also has equal variances in there as well. They're nested, the models. That's important. So that means that we cannot, or we reject the hypothesis that the means are equal. So we reject the null hypothesis that the means are equal here, and that gives evidence for the alternative that the means are not equal. And if we want, we can zoom in a bit more. So this is a multivariate test. It's basically a hot length t-test for latent variables. We can zoom in more to post hoc test and then see, okay, which of these means differ across groups, right? And then you can look at the parameter estimates, or you can just do partial invariance, but then for the homogeneity test. So I can do group partial and then put the means here as well, things like that. So now that we, does the model still fit? That's of course also important, but I mean, if we have been improving the model so far, or not improving, but rather not making it worse, so that means that we get parsimonious models that fit well, then we should expect it to still fit, but you do want to check that, of course. So this is okay. Messier is okay. This is all good. Well, here's a bit lower than expected. SRMR might have been a bit lower ideally, but this is all fine. So we would probably say this is adequate fit. So that means that we can now interpret differences in these groups. And so we can look at the alpha. And actually what I do here is I look at the alpha estimates for group 2, so that's alpha 2, which indicates the difference between these groups. And then this tells me that the speed is lower in group 2, in school 2, but especially this textual has a big difference here compared to between the groups. So that might tell us something about the education plans between these schools, for example. Okay, and that's it for homogeneity testing. It's really the same principle as measurement invariance testing, but we first want to establish measurement invariance or partial measurement invariance before we can do these homogeneity tests and look at the thing that we might be really interested in if these groups differ or not. And that's it for all the video lectures for this week. So good luck with the assignment and also good luck with the final project. We'll start gathering data as well this week. So that's going to be an exciting time.